Hello all. In this video we're going to take a look at different ways that you can walk through a program that has a function in it to understand and to visualize what's happening with the function call. So we're going to do this similar example to the one we did in the previous video, but we'll look instead at doing it by hand and drawing out environments. And then I'm going to show you an online tool that you can use that will it's a little iffy, but you can use it to actually visualize step by step what's going on. And then we'll also take a look at the Python debugger. This is a tool that's part of PyCharm that will actually let you step by step walk through the program and see what all the values of all the variables are. It's kind of a nice tool, and if you like it, you can keep using it as much as you like. All right, so I've gone back to my notes. We have our definition of smallest diff that we were talking about before, and I'm going to pick a different example. So I did one example in the previous video. Here I'm going to take this example, smallest diff 395. So we know what this should do. It should compute the difference between 3 and 9, and between 9 and 5, and between 3 and 5, and report whichever one is smallest. That's the purpose of the program. What we're going to do is walk through what is happening here and make sense of each step along the way, kind of like we did before when we were looking at it in PyCharm, but here we're going to do it more conceptually. Okay, so we'll look at the steps that happen when you make the function call. The first step, Python matches the function name from the call down here at the bottom to the function definition, and it says, this is the function that we're calling. It makes sure that they have the right number of inputs. So this has 3 inputs, so we better have 3 arguments. We have 3 input parameters, so we need 3 arguments. And then it evaluates each of these arguments. They could be whole Python expressions themselves, but they get evaluated and the values are assigned to X, Y, and Z. And this is the first place where something new happens. So in step 2, we build a local environment. This is basically a table inside the computer that's attached to this function call, and where we have a row in the table for each variable, and associated with each variable is its value. So X gets the value 3, Y gets the value 9, Z gets the value 5. This table is an actual thing that the program is keeping track of, so that it knows if we ever reference X, Y, or Z, that we should actually find it here. And when it sees a variable in the body of the program, it will first look at this table in the body of the function. It will first look at this table. If it doesn't find it here, then it will look out in the global level. All right, so building the local environment table is part of doing the function call. Step 3 of the function call is to actually perform the indented steps in order. They could have for loops, they could have if statements that change the order, but generally speaking, you think of it as just for now in order. It will perform each line. Those lines that create new local variables, those local variables will get added to our local environment. So we perform diff1 equals abs of x minus y. X and y are looked up in the table. They are 3 and 9. We take the difference. We get 6. So diff1 is added to our local environment table with the value 6. Next, we do the next line. Diff2 equals abs of y minus z. Y is 9, Z is 5. Take the difference and take the absolute value, you get 4. Diff2 is added to the table with a value of 4. And then we do it again. Diff3 is the absolute value of x minus z. 3 minus 5 is negative 2. We take the absolute value, that's 2. So diff3 is 2. Only a couple lines left in the function. We calculate the minimum of diff1, diff2, diff3. So when it sees these variables, diff1, diff2, and diff3, it's going to look in this table first and find their values there. It won't see any, if there was a global variable named diff1, it's completely separate from this one. This one is isolated and kept separate from the rest of the world. So we look at 6, 4, and 2, and the minimum of those is clearly 2, so min diff gets assigned the value of 2. The last line of the function says return min diff. And so it takes the value 2 that was stored in that table, and it passes it back into this expression so that this expression becomes, in effect, s equals 2. So s gets assigned to hold the value that comes back from the function. At that point, the function call is over. And so when the function call ends and we get back here and we finish this assignment statement, at that point, all of that local environment gets erased because we're done. We've called for smallest diff and it finished. So the local environments are the word I always think of is ephemeral. They are there while the call happens and then they go away again. And if we make another call, they'll come back into being with new values and then they go away again. It is the nature of local environments to do this. All right, so that's walking through the program by hand. It's a really good skill to be able to do this, and you might want to practice this with teammates or with friends until you feel comfortable doing it. I'm going to switch over to, well, I guess I'll show you this Python code visualizer. I'm going to go back because I was actually doing an example. Okay, so down here, this is where you put your code. And what I'm going to do is copy the smallest diff, and then I'm just going to do s equals smallest diff of, 3, 9, and 5, right? That was the example that we had before. This is a random website. It often has ads on it that are kind of annoying, but it does a good job of illustrating each step in the process. It's actually AI driven, but this is actually not a bad use for AI. All right, we're going to visualize the execution of this. So in this visualization, it shows a red arrow. That's the current line of code that's being performed, and it will explain what is happening to us as we go. So I'm going to say, okay, it's at the def line, at that function definition. And what it says is we are adding to the global frame. A frame is another word for an environment. We're adding to the global environment the variable smallest diff, and the value associated with it is the function smallest diff that was defined right here. That's what I mentioned this at an earlier point. The definition, that variable goes in the global environment. The value is the function definition itself, and it just sits there. We've added it, but nothing has happened with it yet. Notice now we've moved down, so we are at this line, and that's what we're going to perform next. So the next thing we do is to start the function call. Smallest diff 3, 9, and 5, and here you can see this is a local frame or a local environment, just like in our by hand example, showing us the value of x, y, and z. It's 3, 9, and 5. And then it's going to start executing the indented lines that are part of the function. Calculates diff 1, calculates diff 2, calculates diff 3, computes the minimum, and then we return the value. So the return value is 2. That's going to come back here, and notice that we've added to our global environment that s is going to be assigned to 2 once we finish that line. So I find this an interesting tool. I think it works relatively well. I wouldn't try it on anything too complicated or special purpose, but it's nice for just giving you the sort of step-by-step view of what's going on in a very intuitive way. What I'm going to do next is to switch over to PyCharm, where we already had our definition of smallest diff. I'm going to take out some things. We're going to take out this print statement, and I'm going to take out this print statement. And and I'm going to change these values to be 3, 9, and 5, which were the values in our other examples. So I want to use the Python debugger, and to call the debugger, we use this little bug icon up here at the top. That will trigger the debugger instead of the program the normal run. I can do that right now. It prints a whole lot of things, and then it just basically says small equals 2, and it didn't look like it was very helpful at all. When you use the debugger, one of the things you need to do is to stop it. If you don't tell it where to stop, it will just run through the whole program and not really tell you anything useful. So you may have done this accidentally yourself, but if you run your mouse up or down over the line numbers, you'll see that there's a little red dot that appears, kind of a ghostly red dot. That is called a breakpoint. And a breakpoint in a program is a place where, and actually I'm going to put the breakpoint right up on line 1. No, it won't let me. Okay, we'll put it on line 2. A breakpoint is a place where the debugger will stop. When it gets to the breakpoint, as it's running through the program, it will stop what it's doing and let you then step through the program from that point, let you look at the variables that are there, and just basically look around at what's going on. So I'm going to set a breakpoint right at the very first line of code, and then I'm going. Sorry about that. I had an issue where it was not stopping on the def line, so I moved my breakpoint down to the first script line after the function definition, and that seems to make it much happier. So we're going to start there. All right, so I hit the run, and now what you see is both the run button and the stop button are lit up. We are in the middle of running the program, but we've paused it. The debugger has stopped at this line. And so it'll show us a couple of things down below. This is where you see very interesting things happening. You can look at the console, which shows you the output from the program. Threads and variables. Variables are what we're going to be looking for here. And this shows you what is actually running. So right now it's running the code file, the module, pythonexamples.py. It's on line 9. Let me see if I can stretch this out a little so we can see it a little better. So functionexamples.py on line 9 is not really doing anything else. Now I could hit a number of buttons at this point, some of which would just cause it to keep running. So up here, this restarts the whole thing with the debugger. This stops our debugging session. This says resume the program, so it would just go ahead and finish. Let's just click that to see what happens. Whoosh! It finished and it printed small equals 2. We're going to run it again. Okay. There are other buttons over here that let us control how we walk through the program, but it lets us go step by step through the program. Step into is probably what we want here because there's a function call, and step into will go into the function call. You just want to be careful with that because if you click that while you're on a built-in function, it may very well take you into some very strange code that you won't understand. So there's step into, there is step into my code, which saves you from that. It'll go into anything that is your code file, but it won't go into things that are system files or installed libraries like OpenCV or anything like that. And there's step out, and there's a way to view all the breakpoints. So I'm going to use step into my code because that seems like a nice safe thing to do. This will, when I click this next button, it's going to run or start running the next line of code. All right, now what can you see? It is now at the first line inside the function definition, but a lot of things have happened there. So under threads and variables, it will show us essentially the local environment, the local frame, the local table that has our input values and the parameter variables that they're assigned to. So this is very much what we might expect. It's just a different format of the same table. Notice that it's also showing us this information in two places up here in the editor. It's annotated the call with the variables, and then out here to the right, it's actually showing us those same values again. So it does, the PyCharm editor does a lot of annotation for us. And we are on this first line. I can just keep saying step into my code, and it will go on to the next line of my code. So I'll step one more time. Diff1 gets added. Step again. Step again. This is very much like the other examples that we did. It's just showing you the data in a different form. It also annotates with the values as it goes down. When we get to the return, it's going to come back out again. Small is shown as having the value 2. Special variables, there's probably nothing here that we really need to look at. Oh, well actually, look. Under the special variables, smallest diff is there. I'm going to run this again after we're done just to show that to you. And then I'm just going to say step again, and it's done. I want to run it again because I want to show you a couple more things that I didn't point out the first time. All right, so here we are. We're at this point. We've already gone past this code and done the function definition. So if we look at special variables, smallest diff is there. It's defined as a variable that holds a function. This weird code that's off to the right, that's actually a memory address. That's where that function is stored in memory. We also have some other things, like notice that it knows what file it's running. It has some other information as well, right, along the way. As we're stepping, I'm going to step through this program again. I want to focus now on what's going on in this main thread section. So I hit the step. This I didn't point out last time. So we started off with module function examples.py line 9. That's still there because we aren't done with it yet. We have to finish the call to smallest diff, come back and define small to be the result. So this line is still waiting to be finished, but now it's showing us that it's in another function. It's in the function smallest diff, it's on line 3, and as I step, you'll see that that line number will change. And then when we come back to our main code, that goes away, and we're now on line 10. We finish up. So I think the debugger is a really helpful tool when you need to figure out what's going on with a function. If you can't figure it out walking through it by hand, try going through it with the debugger. Our ultimate goal, though, is that you should be able to read the code and walk through it by hand and understand what's happening. All right, so here we've shown you several different ways of working through a function to figure out exactly what will happen when it's called. These are really useful when you're trying to debug your code, but also if somebody gives you some code and you aren't sure what it does and you need to figure out what's happening, then any of the methods that we've used in this video would be helpful for you in that case. We're going to see some more advanced examples, functions that call other functions, main functions, in another video, and I will see you very soon in the meantime.